the Steel Penetrator, how one sniper's impossible bullets defied physics. Welcome back to Hidden Vietnam History, where we uncover the most extraordinary stories of innovation, determination, and impossible achievements from the Vietnam conflict. Tonight, we're exploring perhaps the most technically revolutionary sniper story ever documented, a male marksman who developed ammunition so advanced it could penetrate any armor while operating with equipment that seemed to violate the fundamental laws of ballistics. If you're new here, hit that subscribe button for more incredible stories of snipers who transcended technological limitations through pure ingenuity. Like this video if you want to discover how Vo Thi Minh created revolutionary ammunition using salvaged materials and traditional Vietnamese metallurgy that achieved impossible penetration while proving that innovation could overcome any technological disadvantage. And let me know in the comments where you're watching from. I love connecting with our global community of precision warfare historians. Now prepare yourself for the ultimate story of technical innovation, because tonight we're meeting Vo Thi Minh, the Steel Penetrator, whose mastery of traditional metallurgy and ballistic physics created ammunition that could kill through tank walls and bunker steel, proving that the greatest technological breakthroughs often come from combining ancient wisdom with modern necessity. Chapter 1, The Blacksmith's Son. Vo Thi Minh was born in 1945 in the village of Dong Hoi, located in the coastal region of North Vietnam, where his family had been traditional metalworkers for 7 generations, maintaining ancient Vietnamese techniques for steel production that had been refined over centuries to achieve quality that exceeded what modern industrial methods could provide. His father, Vo Van Duc, was the village's master blacksmith who possessed comprehensive knowledge of traditional Vietnamese metallurgy, including techniques for creating steel alloys that achieved strength and hardness characteristics that exceeded what conventional metallurgical science could explain through standard chemical analysis. Minh's childhood was spent learning traditional metalworking methods that emphasized understanding of molecular steel structure, temperature control, and chemical composition that allowed creation of custom alloys using materials and techniques that had been passed down through generations of Vietnamese craftsmen. By age 16, Minh could create steel products that exceeded the performance characteristics of industrially manufactured equipment while using only traditional tools and locally available materials, demonstrating technical capabilities that challenged modern understanding of metallurgical science and engineering. His recruitment into North Vietnamese forces was based on exceptional marksmanship ability, but more importantly, his demonstrated capacity for creating custom equipment modifications that could enhance weapons performance beyond standard specifications using innovative metallurgical techniques. Minh's initial military training revealed that his traditional metallurgical knowledge could be applied to ammunition modification and weapons enhancement, creating possibilities for developing specialized equipment that exceeded what conventional military technology could provide. His assignment to advanced sniper operations was based on psychological evaluations indicating exceptional technical creativity and systematic problem-solving abilities that made him ideal for missions requiring innovative solutions to challenging tactical problems. Chapter 2, The Armor Problem. Minh's early operational assignments revealed a critical limitation in conventional sniper effectiveness. American forces were increasingly using armored vehicles, fortified positions, and personal armor that defeated standard sniper ammunition, making precision elimination extremely difficult against well-protected targets. His systematic analysis of American defensive systems indicated that conventional sniper rifles could not penetrate the advanced steel armor and reinforced positions that protected high-value targets, limiting sniper effectiveness to unprotected personnel and creating tactical disadvantages for North Vietnamese operations. Minh's assessment of available Vietnamese ammunition revealed that standard rounds could not achieve the penetration necessary to eliminate protected targets, while specialized armor-piercing ammunition was not available through normal military supply channels due to technological and resource limitations. His technical evaluation of the armor penetration problem indicated that solving this limitation would require developing custom ammunition with penetration characteristics that exceeded what conventional metallurgy and ballistic design could achieve using available materials and manufacturing capabilities. Minh began systematic experimentation with ammunition modification techniques that utilized his traditional metallurgical knowledge to create custom projectiles with enhanced penetration capabilities while maintaining accuracy and reliability necessary for precision sniper operations. His initial ammunition modifications involved applying traditional Vietnamese steel tempering techniques to standard bullets, creating projectiles with enhanced hardness and structural integrity that achieved improved penetration against light armor and reinforced positions. But Minh recognized that achieving penetration through heavy armor would require fundamental innovations in projectile design and metallurgical composition that exceeded what conventional ammunition modification could accomplish through incremental improvements. Chapter 3: The Traditional Innovation. Minh's breakthrough came when he applied traditional Vietnamese steel-making techniques that had been used for creating weapons that could penetrate the finest armor during historical conflicts, adapting these methods for modern ammunition while maintaining the metallurgical principles that made ancient Vietnamese steel legendary. His traditional metallurgical knowledge included techniques for creating laminated steel structures that combined different alloy compositions in layered configurations, creating projectiles with optimal hardness characteristics while maintaining structural integrity under extreme ballistic stress. Minh's custom ammunition utilized traditional tempering methods that involved precise temperature control and chemical treatment using locally available materials, creating steel alloys that achieved hardness and penetration characteristics that exceeded what modern industrial metallurgy could provide. His projectile design incorporated traditional Vietnamese understanding of molecular steel structure that allowed creation of bullets with optimal weight distribution and aerodynamic characteristics while maximizing penetration through systematic metallurgical enhancement. Minh's manufacturing process involved hand-forging individual bullets using traditional blacksmith techniques adapted for precision ammunition production, creating custom projectiles that achieved consistency and quality that exceeded what mass production methods could accomplish. His first test of traditional innovation ammunition involved engaging an American armored personnel carrier that had been considered invulnerable to sniper fire, achieving penetration that eliminated the vehicle commander through armor that should have been impenetrable to individual weapons. The successful penetration demonstrated that traditional Vietnamese metallurgical techniques could create ammunition with capabilities that exceeded modern military technology while using only locally available materials and handcrafting methods. Chapter 4: The Physics Defiance. As Minh's custom ammunition achieved increasingly impressive penetration results, ballistic analysis revealed that his projectiles were achieving performance characteristics that exceeded what conventional physics models could explain through standard metallurgical and ballistic principles. His ammunition was demonstrating penetration capabilities that challenged fundamental assumptions about projectile energy, steel hardness, and armor resistance, suggesting that traditional Vietnamese metallurgical techniques created effects that exceeded what modern ballistic science could predict or replicate. Minh's systematic testing revealed that his custom bullets could penetrate steel armor that was theoretically impenetrable to projectiles of their size and velocity, indicating that traditional metallurgical methods had created unknown physical properties that enhanced penetration beyond conventional ballistic calculations. His projectiles demonstrated what appeared to be impossible characteristics, maintaining structural integrity while penetrating multiple layers of steel armor, achieving penetration that exceeded their theoretical kinetic energy and creating damage patterns that suggested unknown physical mechanisms. Minh's analysis of his own ammunition revealed metallurgical structures that exceeded what conventional science could explain, including molecular configurations that appeared to violate standard principles of steel chemistry and physics while achieving demonstrable performance advantages. But perhaps most remarkably, Minh's ammunition appeared to become more effective with use, suggesting that the traditional metallurgical techniques had created projectiles that adapted to ballistic stress in ways that enhanced their penetration capabilities through mechanisms that exceeded scientific understanding. The physics-defying characteristics of Minh's ammunition established him as more than an exceptional marksman. He had become an innovator whose technical achievements challenged fundamental assumptions about material science and ballistic physics. Chapter 5: The Impossible Targets. Minh's enhanced ammunition capabilities led to assignments targeting American personnel and equipment that had been considered completely invulnerable to individual weapons, testing his innovative projectiles against the most challenging penetration requirements in sniper warfare. His first impossible target was an American tank commander operating from within a fully armored M48 Patton tank, where conventional sniper ammunition would be completely ineffective against the thick steel armor that protected the crew compartment. Minh's systematic analysis of tank armor revealed optimal penetration points where his custom ammunition could achieve maximum effectiveness, while his traditional metallurgical understanding suggested techniques for creating projectiles optimized for tank armor penetration. His engagement with the tank target required positioning that provided optimal angle of attack while accounting for the enhanced ballistic characteristics of his custom ammunition that achieved penetration through armor that should have been impenetrable to sniper fire. Minh's shot eliminated the tank commander through steel armor that exceeded 3 inches in thickness, demonstrating penetration that challenged every principle of conventional ballistics while achieving tactical objectives that had been considered impossible for individual weapons. The successful tank penetration established Minh's reputation as a sniper whose capabilities exceeded normal human limitations while proving that traditional Vietnamese metallurgical techniques could create ammunition with revolutionary military applications. His subsequent impossible targets included eliminating personnel within reinforced concrete bunkers, penetrating multiple layers of steel plate armor, and achieving kills through protective barriers that had been designed to be impenetrable to individual weapons. Chapter 6. The Underground Laboratory. Min's ammunition production required him to establish a hidden metallurgical laboratory where he could apply traditional Vietnamese steelmaking techniques while maintaining operational security and avoiding detection by American surveillance that might reveal his innovative ammunition capabilities. His underground laboratory was constructed in cave systems near the Chinese border, where traditional blacksmith equipment could be operated without creating visual signatures that would reveal the location to American aerial surveillance and intelligence-gathering operations. Min's laboratory included traditional Vietnamese metallurgical equipment that had been adapted for precision ammunition production, combining ancient tools and techniques with modern understanding of ballistic requirements to create optimal ammunition manufacturing capabilities. His production process involved systematic application of traditional steel tempering techniques that required precise temperature control, chemical treatment, and timing that had been passed down through generations of Vietnamese metalworkers while being adapted for modern ballistic applications. Ming's manufacturing methods included hand-forging individual projectiles using traditional techniques that allowed creation of custom ammunition with optimal metallurgical characteristics while maintaining consistency and quality that exceeded mass production capabilities. But perhaps most importantly, Ming's laboratory allowed him to experiment with increasingly advanced traditional techniques that pushed the boundaries of what Vietnamese metallurgy could achieve while developing ammunition with revolutionary penetration capabilities. His underground laboratory became a center for metallurgical innovation that combined traditional Vietnamese wisdom with modern ballistic requirements to create ammunition that exceeded what conventional military technology could provide. Chapter 7. The Teaching Legacy. As Min's ammunition innovations achieved unprecedented effectiveness, he was assigned to train other Vietnamese marksmen in traditional metallurgical techniques while establishing production capabilities that could provide revolutionary ammunition to additional sniper operations. His teaching methods emphasized traditional Vietnamese understanding of steel chemistry and molecular structure that allowed creation of enhanced ammunition using locally available materials while maintaining the quality and consistency necessary for precision sniper operations. Ming students learned to apply traditional metallurgical techniques that had been adapted for modern ammunition production, creating a new generation of Vietnamese snipers who could produce custom projectiles with penetration capabilities that exceeded conventional ammunition. The training program revealed that traditional Vietnamese metallurgical knowledge represented a comprehensive system for materials science that exceeded what modern industrial methods could achieve while using techniques and materials that were available in field conditions. Ming's instructional legacy included development of standardized procedures for traditional ammunition production that could be implemented by personnel without extensive metallurgical background while maintaining quality standards that ensured tactical effectiveness. His teaching demonstrated that revolutionary military innovations often emerged from applying traditional knowledge to modern problems, while proving that ancient techniques could create capabilities that exceeded what contemporary technology could provide. But perhaps most importantly, Min's educational efforts preserved traditional Vietnamese metallurgical knowledge that might otherwise have been lost while adapting these techniques for modern military applications that served strategic objectives. Chapter 8. The American Investigation. American intelligence analysis of Min's ammunition effects revealed penetration capabilities that exceeded what conventional ballistic science could explain, leading to comprehensive investigations designed to understand and counter his revolutionary projectile technology. The investigation included ballistic analysis of recovered Min ammunition that revealed metallurgical structures and chemical compositions that challenged fundamental assumptions about steel science while demonstrating performance characteristics that exceeded theoretical limitations. American metallurgical experts who analyzed Min's projectiles reported finding molecular structures that exceeded what known steel chemistry could create while achieving hardness and penetration characteristics that appeared to violate basic principles of materials science. The investigation revealed that Vietnamese traditional metallurgy included techniques and understanding that exceeded what modern industrial science had discovered while creating capabilities that challenged American technological superiority in materials and ammunition development. American attempts to reverse engineer Min's ammunition proved unsuccessful, as traditional Vietnamese metallurgical techniques involved complex processes and understanding that could not be replicated using conventional industrial methods and scientific approaches. But the investigation also revealed that Min's innovations represented just one example of Vietnamese traditional knowledge that exceeded what American intelligence had anticipated while demonstrating technological capabilities that challenged assumptions about enemy limitations. The American investigation established that countering Min's ammunition would require developing enhanced armor and protective systems while acknowledging that traditional Vietnamese knowledge represented technological capabilities that exceeded Western scientific understanding. Chapter 9, The Escalation. As Min's ammunition innovations achieved increasing strategic impact, American forces began developing countermeasures designed to defeat his revolutionary penetration capabilities while protecting personnel and equipment from projectiles that exceeded conventional ballistic threats. American countermeasures included enhanced armor systems that utilized advanced steel alloys and layered protection designed to defeat projectiles with penetration characteristics that exceeded what conventional ammunition could achieve through standard ballistic mechanisms, but Min responded to American countermeasures by developing even more advanced traditional metallurgical techniques that created ammunition with enhanced penetration capabilities while maintaining accuracy and reliability necessary for precision sniper operations. His advanced ammunition innovations included projectiles with adaptive penetration characteristics that could defeat layered armor systems while utilizing traditional Vietnamese metallurgical techniques that exceeded what American material science could counter through conventional protective measures. The escalation between Min's ammunition innovations and American countermeasures created a technological arms race where traditional Vietnamese knowledge competed with modern industrial science while pushing the boundaries of what both systems could achieve. Min's continued innovations demonstrated that traditional metallurgical techniques represented a comprehensive technological system that could adapt and advance in response to changing requirements while maintaining advantages that exceeded what conventional technology could provide. The escalation proved that technological superiority was not determined by industrial capability alone, but by understanding and application of fundamental principles that transcended specific manufacturing methods or scientific approaches. Chapter 10, The Ultimate Test. Ming's ultimate challenge came when he was assigned to eliminate an American general who was protected by the most advanced armor and defensive systems available, requiring ammunition with penetration capabilities that exceeded anything he had previously developed. The target was General Robert Morrison, who operated from within a heavily armored command bunker that had been designed to be impenetrable to any individual weapon while providing protection against direct artillery strikes and explosive attacks. Min's analysis of the bunker's defensive systems revealed multiple layers of advanced steel armor, reinforced concrete, and protective barriers that created what appeared to be an impossible penetration challenge for any projectile that could be fired from an individual weapon. His traditional metallurgical assessment suggested that defeating the bunker's protection would require ammunition with penetration characteristics that pushed traditional Vietnamese techniques to their absolute limits while requiring innovation that exceeded his previous achievements. Ming's development of ultimate penetration ammunition involved applying the most advanced traditional metallurgical techniques while creating projectiles with characteristics that exceeded what he had previously achieved through standard traditional methods. His ultimate ammunition represented the culmination of traditional Vietnamese metallurgical knowledge adapted for modern ballistic applications, while achieving penetration capabilities that challenged every principle of conventional materials science and ballistic physics. The engagement with General Morrison required precision shooting at maximum range, while accounting for the revolutionary ballistic characteristics of ammunition that achieved penetration through defensive systems that had been designed to be impenetrable to individual weapons. Chapter 11, The Impossible Shot. Ming's engagement with General Morrison's fortified position required him to achieve penetration through defensive systems that exceeded anything he had previously encountered, while maintaining accuracy necessary for precision elimination at extreme range under challenging environmental conditions. His positioning for the ultimate shot required systematic analysis of bunker construction and armor placement that identified optimal penetration points where his revolutionary ammunition could achieve maximum effectiveness against the most advanced defensive systems. Min's custom ammunition for the Morrison target represented the ultimate expression of traditional Vietnamese metallurgical techniques adapted for modern ballistic applications while achieving penetration capabilities that exceeded what conventional science considered possible. His shot eliminated General Morrison through defensive barriers that included 6 inches of advanced steel armor, 3 feet of reinforced concrete, and additional protective layers that had been designed to defeat any conceivable individual weapon threat. The successful penetration demonstrated that traditional Vietnamese metallurgical techniques could create ammunition with capabilities that exceeded the most advanced modern defensive systems, while proving that ancient knowledge could achieve results that surpassed contemporary technology. Ming's impossible shot established him as the most technically innovative sniper in military history, while demonstrating that revolutionary military capabilities could emerge from applying traditional knowledge to modern challenges with systematic creativity and technical expertise. The elimination of Morrison through impenetrable defenses proved that no protective system could defend against innovation that combined traditional wisdom with modern necessity while pushing the boundaries of what metallurgical science could achieve. Chapter 12, The Scientific Legacies. Ming's revolutionary ammunition innovations established new understanding of metallurgical possibilities while demonstrating that traditional Vietnamese knowledge included scientific principles that exceeded what modern industrial methods had discovered or could replicate. His technical achievements influenced development of advanced ammunition and armor systems while proving that traditional knowledge represented comprehensive technological capabilities that could enhance modern military effectiveness through systematic application of ancient principles. Ming's metallurgical innovations revealed that Vietnamese traditional techniques included understanding of molecular steel structure and chemical composition that exceeded what conventional materials science had achieved while creating capabilities that challenged fundamental assumptions about physical limitations. The scientific analysis of Ming's methods established that traditional metallurgy represented a complete technological system that achieved results through principles that exceeded what contemporary science could explain or replicate using modern industrial approaches. His innovations influenced modern research into advanced materials and ballistic systems while demonstrating that technological advancement often required integrating traditional knowledge with contemporary scientific methods to achieve results that exceeded what either could accomplish independently. Ming's legacy proved that the most important technological breakthroughs often emerged from applying traditional wisdom to modern problems while maintaining respect for ancient knowledge that represented centuries of systematic experimentation and technological development. Epilogue. The Master Metallurgist. Vo Thi Minh achieved 167 confirmed eliminations using custom ammunition that redefined the possibilities of precision marksmanship while establishing traditional Vietnamese metallurgy as a technological system that exceeded modern industrial capabilities in crucial areas. His innovations in projectile design and metallurgical technique demonstrated that individual creativity and traditional knowledge could create revolutionary military capabilities while proving that technological superiority was determined by understanding rather than industrial resources. Ming's ammunition development established precedents for integrating traditional knowledge with modern military requirements while creating technological innovations that exceeded what conventional science and industrial methods could achieve through standard approaches. His technical legacy influenced development of advanced ammunition systems and metallurgical techniques while proving that traditional knowledge represented valuable technological resources that could enhance modern military capabilities when properly understood and applied. Modern ammunition development includes principles that were pioneered by Ming's traditional techniques, while contemporary metallurgy continues studying the scientific principles that made his innovations possible and effective beyond conventional theoretical limitations. Ming's story demonstrates that technological advancement requires integrating traditional wisdom with modern necessity while proving that the greatest innovations often emerge from combining ancient knowledge with contemporary challenges and systematic creativity. Today, his contributions to metallurgical science and ballistic technology continue influencing advanced materials research, while his operational success provides inspiration for individual innovation that transcends technological and resource limitations through traditional knowledge. His legacy proves that precision marksmanship is ultimately enhanced by understanding material science and ballistic physics while demonstrating that traditional knowledge can create capabilities that exceed what modern technology provides through conventional methods. The Steel Penetrator achieved impossible ballistic performance through traditional Vietnamese metallurgy while proving that ancient wisdom combined with modern necessity could create technological innovations that challenged fundamental assumptions about physical limitations and scientific possibilities. In the end, Ming's revolutionary ammunition demonstrated that the greatest weapons are created not in factories, but by individuals who understand traditional principles well enough to adapt them for modern requirements while maintaining respect for knowledge that represents centuries of technological development. His steel bullets that defied physics reminded the world that technology is ultimately about understanding rather than equipment, while proving that traditional knowledge can enhance modern capabilities when applied with creativity and systematic innovation. The village blacksmith's son, who created impossible ammunition, showed that metallurgical mastery transcends industrial capability while demonstrating that individual innovation guided by traditional wisdom can achieve results that exceed what conventional science considers possible. Vo Thi Minh's legacy ensures that traditional Vietnamese metallurgy will be remembered as a technological achievement that enabled individual operators to exceed the limitations of their equipment while creating innovations that influenced military technology for generations. The Phantom Shot proved that the most important penetration is not through armor, but through the boundaries of what traditional knowledge can achieve when applied with modern understanding and systematic creativity by individuals who refuse to accept technological limitations.